Good morning, students. Our today's topic in the subject of physics O levels is the center of gravity. Important topic this is, so concentrate yourself. We are going to start. The center of gravity of an object is defined as the point through which its whole weight appears to act for any orientation of the object. This is the definition of the center of the gravity. For a regular object, the center of the gravity is at its geometrical center. So here are some regular objects. So their center of gravity is at their geometrical center. Look at, this is the center of every regular object. So their center of gravity lies there. But if we are given irregular object, a plumb line is needed to find its center of gravity. The procedure will be: make some holes at the edges of the irregular object, and the object will be hang on one of the hole, and a plumb line will be hanged with it as well. After the things getting into stationary, we will write a line. We will draw a line on the plumb line. Then object will be withdrawn and hang on the other hole, and same procedure will be repeated. Then hang on the third hole, same procedure will be repeated. Where most of the lines intersect, that point of intersection will be the center of gravity. So this is the procedure for finding the center of the gravity of an irregular object. Okay, next topic in the lecture is stability. There are three kinds of the equilibrium, namely stable, unstable, and neutral equilibrium. So these are the three kinds of the equilibrium: stable, unstable, and neutral equilibrium. The stability of an object can be improved by, this is very important point, the stability of an object can be improved by lowering the center of the gravity, this is the first step, and increasing the base area of the object. So these are the two steps through which we can increase the stability of any object. Now we are going to read the three kinds of the equilibrium one by one. The first type is stable equilibrium. So this is a kind of stable equilibrium. Look now, what happened in this stable equilibrium? In figure, the cone is in stable equilibrium because if it is tilted slightly, it returns to its original position without toppling. So if we disturb slightly, it will come back to its original position. Note that when you tilt the cone slightly, these points actually happen in stable equilibrium. First, its center of gravity rises and then falls back. Look, center of gravity rises and then falls back again when the cone is released. Second, the line of the action of the weight W lies inside the base area of the cone. So this is the line of the action of the weight that lies inside the base area. This is the second property of the stable equilibrium. The third property is the anti-clockwise movement of the weight W about the point of the contact C causes the cone to return to its original position. So when we rise the object and release it, it will come back. So anti-clockwise movement actually of the weight W about the point C causes the cone to return back to its original position. So if these three properties applies in any object, that will be in stable equilibrium. Next, we are going to read unstable equilibrium. This is a kind of the unstable equilibrium. If the cone is in unstable equilibrium because if it is tilted slightly, it will topples over. Note that when you tilt the cone slightly, these three properties actually applied. Number one, its center of gravity falls and continues to fall. Here is the center of gravity that falls and continues to fall. The line of the action of the weight W lies outside of the base area. In the beginning, this was the center of the, this is the line of the action of the W. Actually, when we tilt it, that comes outside of the base area. Number 3, the clockwise movement of the weight W about the points of the contact C causes the toppling effect. So when we tilt it, actually clockwise movement causes it to the toppling effect. So these are the three properties. These three properties, whenever applies on any object, that object comes into the unstable equilibrium. The next type is neutral equilibrium. This is a type of the neutral equilibrium. Look now. In the figure, cone is in neutral equilibrium because if it is rolled on its side, it will stay in its new position, and these three properties will be applied in neutral equilibrium. Number 1, its center of gravity neither rises nor falls. It remains at the same level. So if we roll the ball, in the beginning this is the center of the gravity, and at the end this is the center of gravity. It neither rises nor falls. It remains at the same position. Number 2, the line of the action of the two forces W and R always coincides. So line of the action of the W and reaction always in the same line. So this is the second property of the neutral equilibrium. Number 3 is, therefore there is no movement provided by the weight W about the point of the contact to turn the paper cone. So neither the clockwise movement nor the anti-clockwise movement causes the toppling over effect. So this is the third property. And whenever these three properties applies in any object, that object comes into the neutral equilibrium. Now we are going to discuss some questions about this point. The diagram shows cross sections of the 4 solid objects. Which object is most stable? For most stable, for any object, 2 properties must be applied. Number 1, its center of gravity must be lowered as maximum as possible, and secondly, increase the base area. So these are the 2 properties. Whenever these 2 properties applied in any object, that comes into the most stable position. So look at the 4 objects. Here is the object B, that is having the most of the base area and center of gravity as low as possible. So look, B, the object has the lowest center of the gravity and the widest base. The next question is, books are placed in 4 bookcases as shown. So here are A, B, C, D, 4 bookcases in which books are placed. Which bookcase is most likely to fall forward if pulled a little? So again, 2 properties will be applied, center of gravity and the widest base. So base is same for all. It means this factor is balanced in all 4 objects. Now the center of gravity will be mattered. So look at this case. Most of the books are placed in lowered position, so center of gravity will be almost there. Its center of gravity will be almost there. Its center of gravity will be almost there because most of the books are placed there. But in this case, if you see, most of the books are placed in the upper portion, so center of gravity will be there. So this will be in most unstable position. So because the question was which bookcase is most likely to fall forward. So look now, there are more books placed in bookshelf A, placed in the upper shelves in the bookcase. So this causes the center of the gravity to be higher and the bookcase to be least stable amongst all. Here is another question. The tractor is being used on the rough ground. What is the safest position for its center of gravity? So safest position for the center of gravity should be as low as possible. This is the main point. For the stability, 2 points are there. Remember them. Number 1, widest base. Number two, center of gravity should be as lowered as possible. So because the question is, what is the safest position for his center of gravity? And here are some points given. So points given, so we have to choose the point that is as low as possible. So D is the point which is on the most lower position out of 4. So look now, D. The center of the gravity should be as low as possible so that the tractor can be more stable. Okay, here are now two very important questions as far as paper number 2 is concerned from this topic. So look now, figure illustrate both the rest position and the displaced position of a weighted toy. So here is a weighted toy, this is the rest position and this is the moving position. So G is its center of gravity. This is the center of gravity. Explain briefly why the toy returns to its rest position when displaced and released. So look now, these are the steps which you have to learn and understand, because this kind of question always come in paper number 2 from this topic. The center of the gravity is the point through which the weight of the object acts. First you have to give the definition of the center of gravity. When it is at rest, the point G is directly below the pivot. So this is the point which is just below the pivot. When it is displaced, G is displaced upward. So when this is displayed, G will be displaced upward and to the right as shown. So G will be displaced upward and to the right as shown. This is the figure. The weight now has a turning effect about the pivot. The movement of the weight about the pivot causes the toy to turn clockwise. So G will turn the object clockwise and return to its rest position again. So this is the procedure which happens in these kind of toys. Here is another question of this type. Figure shows a reclining seat. The boy on the seat discovers that he can balance in the position shown. So this is the balance position, and rock himself forward and backward by moving his arms as shown by the arrows. So he discovered that if he move his arms like this and this, he can rock himself. So explain this. Look now, steps will be almost same. Before moving his arms, the weight of the boy acting through his center of gravity passes through the point of the contact between the seat and the ground. This is the point of the seat and the ground. The weight of the boy acts through it. Okay, therefore there is zero movement, which explains why he stays at rest. However, when the boy moves his arm towards his feet like this, he will move his arm to his feet. His center of gravity shifts slightly towards his feet. Okay, because weight is moving there. His weight, though constant, acts through his new center of the gravity to create an anti-clockwise movement. So anti-clockwise movement will be created. Movement about the point of the contact between the seat and the ground. Hence, he rocks forward. So that's why anti-clockwise movements will rock him forward. Similarly, when he moves his arms away from his feet towards his head, so when he will move his arms towards his head, the new center of the gravity will be moves towards right. Look now, the center of the gravity shifts slightly towards his head. His weight, which acts through his new center of the gravity, creates a clockwise movement. So now the new weight, the new position of the weight will create a clockwise movement about the point of the contact between the seat and the ground. Hence, he rocks backward. So this is the procedure which actually happens in the reclining seat. So this is one of the very important topic in your physics subject. So read this lecture again, students, and make your notes and learn it. Thank you so much.